Hello everyone and welcome. Good morning. We'll just give it another minute or so that everyone can join, and then we'll kick things off. So I think we can start. Again, hello everyone and welcome for the session today. We have the second session of the GitLab Demo Days series. It will be focused on GitLab CI/CD, but the advanced version. I'm Vlad, I'll be your host today. I'm a solutions architect here at GitLab. I'm based in Bucharest, Romania, and I'll be your host in guiding you through the session today. First of all, let's look at the agenda for the session. So we'll kick things off by doing a quick review of the CICD basics that was covered this Tuesday by my colleague Christoph. Then we'll start discussing about pipeline architectures with a focus on the more advanced options that GitLab offers. Also, talking about controlling when your jobs run, using rules to decide when to trigger a job or not. And also a really important topic will be what we call assembling pipelines from components, templating your pipelines, including them and extending them as needed within your projects, making your pipelines more reusable, more consistent, more compliant, and easier to maintain. Then we'll have a demo where we'll see how everything ties together. And also we'll have a Q&A section at the end. If you do have some questions along the way, don't hesitate to write them in chat or in the Q&A section of this webinar. So, a quick review of GitLab CI/CD basics. Here is what we call the GitLab Flow. Typically, everything starts with an issue. Issues are your work items, your agile planning related stuff, where you collaborate around the problem that you want to address. Then, once you identify the problem and you're ready to start working on it, you're ready to start writing a solution for it, then you should create a merge request. Then afterwards, when you know how the solution would look like, you can start writing your code. It can be through the web IDE or it can be through your preferred IDE. Both options are possible. Once you commit your changes, a CI type of pipeline will run. Maybe part of that pipeline you'll do security scans. We definitely recommend that as a way to shift security as left as possible. Then if you do provide a Kubernetes cluster, we'll deploy a review app, which is a live running replica of your latest changes. Then you do have the option to have a discussion, do code and security reviews, and this happens in the merge request webpage, where everyone has access to all this information in one place. And then you can decide to approve the changes or not. If the change is approved, then the merge request is closed, the issue will get closed as well, and a CD type of pipeline runs that will deploy your application. Then, of course, you can monitor your app through GitLab. So this is shortly how a typical GitLab flow would look like. And within that whole workflow that covers pretty much every step in the software development lifecycle, we do have GitLab CI/CD. with a focus on CICD, we have the source code, we have the commit, as you can see right here. This can be and usually is a trigger for a pipeline. And for the related code of that commit, we'll have a more CI pipeline initially, where we build the app, we test and scan the app, we run any sorts of tests that we want. And then we move to the deployment realm, if you will. We'll deploy a review app, and from there on, with that review app, you can do, for example, dynamic application security testing, performance testing. You can do all sorts of tests and scans that require a live running app. And of course, you can deploy it to staging or testing before deploying it to production. Now, how does a GitLab CI/CD build look like in more detail? Well, we have the pipeline, as already mentioned. This is a set of one or more jobs, optionally organized into stages. Stages are a way to bundle up your jobs together. As you can see right here, we have some examples like build, test, deploy. This is a great way of logically grouping your jobs together. And finally, we have the jobs themselves that contain the scripts, the actions themselves that we need to perform. They can be bash scripts, shell scripts, whatever you need. Finally, we need to use environments as targets for our deployment. And here we can have a lot of environments. As you can see, some of the examples: test, review, canary, and production. And the final piece of the puzzle is the GitLab runner. So everything on the left-hand side will be executed on the GitLab runner itself. You can have one GitLab server and as many runners as you'd like. You can even use your laptop as a runner itself. If you decide to do that, keep in mind that everyone will use your laptop when running pipelines for your project. And that's a quick recap of the basics. Now, let's talk about the first advanced topic of the day, which is pipeline architectures. And today we'll be reviewing actually the basic pipeline. We'll be talking about directed acyclic graphs, parent-child pipelines, dynamic child pipelines, and multi-project pipelines. And with that, let's first of all talk about the basic. As you can see right here on the top, you can see the stages: build, test, and deploy. And part of each of these stages, we have one or more jobs. You do have the option to have the jobs running independently of one another, but all the jobs in one stage need to be completed before moving on to the next stage. This is a pretty basic example just to show you how to get things up and running. Now, in every job, you do have options that you can define and set up. For example, in some cases, not necessarily all of the cases, you might want to have a manual deployment job. Then using a condition like when manual will enable you to do that. You can even pair this with what we call protected environments. So let's say we want to deploy to the production environment and we want to do it manually, and we don't want everyone to be able to do that. Well, having the production environment as a protected environment together with using the when manual keyword, then we are going to achieve this behavior. By default, our jobs have the allow failure parameters set to false, which means that if a job fails, the whole pipeline fails. You can tweak this behavior if you decide for some reason, like we did right here, hey, test A is can be mandatory while test B is optional. If test B fails, there's no problem in that, we can still move on. And also we can dynamically control if a job should be allowed to fail depending on the exit codes. As well, we can decide when a job will get executed. With the when keyword, you have multiple options like delayed, on failure, or always, as you can see right here. Now let's move to more interesting architectures. The first one being DAGs. So we do support DAGs. We have a simple use case for it right here. We are doing a mobile app, and our mobile app is built for Android and iOS. And there's no reason to have the iOS build path or the iOS path have the Android path as a requirement. And as you can see right here, they are running independently. And the way you do that, you can see on the right-hand side. So we have the iOS build job, part of the build stage, and we have a short script. And then we have the same for the Android build, but the main difference comes in the test jobs. You can see right here that we have this needs keyword, and we can specify what job is relying on. And in this case, the iOS job relies on the iOS build, and the Android depends on the Android. The jobs and the pipeline, they are still executed in stages, but they don't need to be longer completed in order for the next stage to begin. This is a big difference from the basics architectures we just looked at. We do have a way of visualizing DAGs, and it looks like this. It might not be the most intuitive of them all, and that's why, based on popular request, we added another view that helps you see better dependencies. And this is part of the UI. You can see different paths and how the dependencies work and are related to each other in your project, based on the needs keyword, of course. Now, the next one, the next category is parent-child pipelines. In general, we do have a parent pipeline, part of a project, and then for some reason, we need to trigger a pipeline in another project. And this can be for multiple reasons. We need to build a dependency, or we need to deploy an application, or anything in between, right? How do we see that in GitLab, and how do we implement it? Well, as you can see right here, the UI looks different, and we do have the same stages and jobs architecture that looks similar, but there's another section that's being added, the downstream pipelines that are getting triggered from any of the jobs that have this keyword attached to them. Now let's look at how this is being implemented with an example for Monorepos. So we have two stages, the build and finalize. We have two build jobs, and we are using only changes to decide what gets executed depending on the type of change. We're using this with the purpose of underlying that only and except are obsolete, and you shouldn't use them anymore. Later on today, I'll be talking about what the alternatives are and what the recommended ways of doing this are. So we do have the build one job. It's part of the build stage, and this will get executed only when we're doing changes in folder project one. What will happen is, if we do any changes over here, then we'll trigger the pipeline that's included in that directory. By using the strategy keyword means that the pipeline needs the main pipeline, the parent pipeline, needs to wait for the child pipeline to be fully executed before moving on. And then pretty much the same happens for build 2. If I want to have a different pipeline when doing changes in another part of my monorepo. And finally, the finalized job will get executed after the execution of any of the previous one. Or in case I do have other folders in my repo when I'm doing a change to them, my build 1 and build 2 jobs will be skipped and I'll just get the finalized job. So you need to be aware of this as you create your pipelines, because GitLab will look for the first match and execute it. If we don't have a match, then nothing will get executed. But we'll discuss this in a bit more detail in the controlling when pipelines run section. The next option, which is similar, it's different but kind of the same, is dynamic child pipelines. So as you can see right here, the structure of my YAML file looks familiar. We do have a couple of stages and we do have a couple of job definitions. The main difference comes from the fact that in my setup job, I'm running a script and I'm generating a pipeline dynamically. I'm using the artifacts keyword to store this dynamically generated pipeline. And then within the test job, I'm including this and executing this pipeline that I obtain. And on the right hand side, you can see how this test.generated-GitLab YAML file looks like. And we are ending the pipeline with the finalize job. And here you can see how it looks like in action. We have this initial quite basic setup of 3 stages, 3 jobs that trigger this child pipeline. But as you can see right here, the replacement based on the script happens, and I'm moving into that dynamically generated pipeline. In some cases where you need to decide on the fly what the content of the pipeline should look like, this would be a good option to use. And finally, multi-project pipelines, they are similar to parent-child and dynamic child in their nature. You do have the option to specify more controls. So in the example right here, we have a test job that's part of the build stage, and we are just echoing I'm building. While we do have what we call a bridge job that will bridge to the other project. And as you can see right here in the section, we are using the trigger keyword. We are specifying the full path to the project and the branch for which we want to run that pipeline. And we're also using the strategy depend keyword again, because we want to wait for the downstream pipeline to be fully executed before moving on with our pipeline. As previously, the downstream pipeline can be anything that you want. The main difference is that I can decide for which branch to run this pipeline. If we have a branching strategy where we are always pushing to master, that works. If we have some longer lived version branches, we can very easily specify, hey, my dependency relies on version 2.5, for example. So we'll use branch 2.5 to build this as we go along. And with that, you can see how this looks like in action, triggering a complete pipeline from my parent project. We can move on to rules. So in summary, we've seen the basic architecture in review. We've seen how you can do directed acyclic graphs with GitLab. we've seen parent-child, we've seen dynamic child, and also multi-project pipelines. Now, what to do with all these pipelines and how we can make them more efficient? This is where the rules come into place. And before talking about rules or why there's a need for rules, we need to discuss a bit about when pipelines are actually executed or triggered in GitLab. So typically on each commit, or when creating a new branch, or even a new tag. And then we have the option to trigger them manually through the UI or through API calls, and finally we can even schedule them. This is important because things can get a bit weird. For the same commit, depending on the trigger and what actually happens, we can have different pipelines, as you can see right here, with different IDs, but the commit remains the same. Well, this ties it to rules, not only as a way of making things more clear, but also more efficient. So when discussing about rules, let's start with the basics first. We do have here a job definition. I guess by now you're familiar with it. We do have a job name, and then we are using the rules keyword. Within or with the rules keyword, we can use a bunch of conditions. In this cases, we're doing an if. We are using the CI pipeline source variable. This is one of the predefined CI variables that GitLab provides. And if that variable is web, then run the script. So with this rule, we are going to only run this job when the source, when it's kicked off from the web form. Again, as a reminder, don't use only and except in your rules moving forward. Now, in terms of clauses, we can use if, as you've seen, changes and exists. And this is where the difference comes between only or moving forward from only and except. And then these are the operators that are available. They look very similar to the ones available in any programming language. And finally, we need to decide what happens with the condition. And here we can use when, allow failure, start in. And here are some of the options that we can use with when, to decide what happens when the rule gets matched. And here's again a quick reference, and just to be aware of what some of the defaults are. So by default, the job will get executed on success, but it won't be allowed to fail. If the job fails, the whole pipeline fails. A job will get added to the pipeline if there's a rule match. And if we have when on success, delayed, or always. If we don't, if the rules don't match, but we do have the last clause, like on success, delayed, and always, even if there's no rule, it will still be added to the pipeline, is kind of a default, if you will. And then if the rules don't match, then the job isn't added to the pipeline. And also we can tweak that with when. Or we can say, hey, we have this rule, but we are using when never to say that we don't want to run a pipeline in this particular situation. So pipelines, or the content of the pipeline, will be somewhat dynamically generated on each trigger, taking into account the exact code changes and checking them against the content of the pipeline. And then GitLab decides what jobs need to be added, and this will be added to the scheduler that we have, And from there on, when the runners reach out to the GitLab instance to pick up jobs, those jobs will be distributed and executed. Now, let's look at a couple of examples of rules in actions so you can get a better feeling of how they should be used. So, first example, we do have a job, we have a simple script, but we have two rules. Again, we are using that CI pipeline source, and we are interested if it comes as if the pipeline is a result of the merge request or if it's on schedule. And with that, we can control what happens with the pipelines that are part of that are the result of a merge request, or if they are scheduled. Now, we have a more advanced example building on the previous one. We do have the same clauses, the same variables, but by using the when never keywords, it means that if the pipeline is generated on a merge request event or on schedule, then I don't want this job to be part of the pipeline. But it can be part of the pipeline in any other case. This is why the when on success keyword does and achieves. Now let's look at another example. And at this point in time, we're going to bring in custom variables, because so far we've only addressed predefined CI variables, but you can also define your own variables and use them into your pipeline. So same structure, we do have a job. It has an action that needs to be performed, specified in the script section. If my custom variable equals false, then I don't want to run this pipeline. As simple as that. But in any other case, run it. Now, a similar example, which contains even more conditions. So in this job, we are going to decide about the Docker build command, and we are going to use a custom variable. And what this does is we're using if the variable has whatever string value we decided, we'll look at changes. If we do have any changes in the Docker file or Docker scripts, in the Docker/scripts path, then this will create a manual job for me that someone will need to click. Otherwise, this won't get executed. Another example, similar, but in this case, we wanna, for some reason, delay this job. We can do pretty much the same. We are using an if, we are using a predefined CI variable, and we wanna aim this job at the master branch. If we are committing stuff to the master branch, then we do want to run this Docker build command, but we want it delayed by 3 hours. And also this is allowed to fail. Otherwise, if we're not committing things to the master branch, then this job won't get executed. And I think this is the last example of rules. I think by now you're starting to get familiar with the structure and how it goes, but we are going to change it up a notch. By adding the workflow keyword, now we are tweaking whole pipelines, not just jobs. So going back to the previous example, you can see that within the job, we have the rules keyword, and then deciding what happens, having the logic. But here we have this workflow keyword and rules. The structure remains very similar. It's just that we are deciding whole pipelines, not just jobs. So workflow rules are a way to decide across a wider set of jobs, a pipeline itself. And in this case, if we do have whip in our commit message, then this pipeline won't get executed because we don't want to do that. Also, if this pipeline was a result of us creating a tag, then we don't want to run the pipeline as well. But in any other case, we want to run the pipeline. I hope this provides some basic information, a starting point, if you will, when dealing with rules, as there are lots of combinations and multiple things that you can achieve with them. Now, moving forward, we're going to address includes and extends. They are really important because they enable you to make your pipelines more reusable, more consistent, more compliant across your whole organization. Because people can use what templates are already available to get up and running. You can validate and confirm those templates. One of the use cases or one of the scenarios that some of our customers are implementing is having a project on their GitLab instance where they are keeping all the CI pipeline templates. And the team that's responsible for it decides what changes are moving forward and what aren't. If you will, it's sort of open sourcing your pipelines where everyone within your company can contribute while you're governing what moves in as a template and what doesn't. And that's easily achievable through includes. With includes, you can add external YAML files, and we do have a couple of options for that. You can include a file that's stored in the local repo within the same project, basically, or you can include a file from a different repo, from a different project within the same instance, GitLab instance, or you can even include a remote file from a URL that must be publicly available currently. And finally, you can use include templates, and this will include the templates that we ship with the community edition. And you can use them as a starting point. In the example right here, we are talking about Auto DevOps, for example, and also what template we do have for Android development. Using includes helps have a smaller, more readable, more maintainable GitLab CI YAML file, because this will get broken down into more files, smaller files, and it's way more easier to manage. Also, as I said, you can have the template stored in a central repo, and project can include and change them, and it avoids duplicated configuration. It helps have that unified, consistent approach, and also we can nest up to 100 includes, even though I don't think we recommend that, as this might be really hard to follow. So once we have the template and we include it through the include keyword, in some cases, we might need to tweak that template a bit. Templates are generally a balance between going too generic or too custom. And in some cases, we need to override that. Well, we do have an examples right here. And you can see we do have a test job definition. And then we are using RSpec. We are defining our own RSpec job that extends the template itself. We are going to overwrite the script section, and then we are going to add some variables as well. You can see the end result on the right hand side. Pretty much with the extend, we are doing a merge. It is an alternative to YAML anchors, and it's way more flexible and readable. It supports multi-level inheritance, but not more than 3. We don't recommend that. And we can merge hidden jobs from regular jobs, or from regular jobs, as you can see right here. Here is an example of using them together. We do have a local file, a local included YAML file that has this really small template. And in our actual pipeline definition, we're going to include that YAML file, and we are going to create a job based on that. The job is use template. We are providing an image to be used for this job, and we are specifying that indeed we are extending that job. Pretty much what will happen in this scenario, we are going to run echo hello on Alpine. It's a very simple example. Recently, we've added the reference keyword, and it's similar in its nature to includes, but you do have the option to select a particular configuration from job sections. And what I mean by that is that I do have the setup template, and in my test job, I'm looking only for the script section to use. And the same in the after script, I want to use just the after script section. And here you can see how this is all merged and what it looks like finally. We do have a way in the UI to see all that, see the final merged YAML file, and also a graphical representation of all the stages and the jobs. And that makes it easier for you to follow along and see how your pipeline will finally look like. And now it's time for demo. So I've been talking a lot, close to 40 minutes now, but let's see how all of this will look like in action. So I do have my demo environment right here, and this demo will be based on release management. So as you can see right here, we do have a front-end application and a back-end application. And also in this subgroup called Group A, we do have some entities where we want to deploy the backend and the front end. Why we decided on this structure is because we wanted a way of managing the front end and the back ends, the whole process, the development, testing, what happens independently from the deployment section. And also, in order to make it more easier to use, we have our own CI templates project that contains all the jobs that we need. So the idea is to, first of all, build the app. And as you can see right here, this is really similar to Auto DevOps, except the deployment looks a bit different. But pretty much we are mentioning what image we want to use as a default in the pipeline. We're specifying some variables and the whole stages. And also here you can see the rules, the workflow rules in action. In this section right here, we are deciding how we should build the app. If you do provide a Docker file, then we are going to use that Docker file to build the container. But if you don't, we are going to use Heroku build packs to do the build. Also, we are deciding what languages are contained within the project, and based on that we are going to decide what security scanners are going to be used. Now this is standard auto DevOps stuff. On top of that, we added a release job. So what happens is with this job is that we are going to use the release image we provide, and here we have rules. If we do have a commit tag, so run this job when a tag is created manually, then we are going to run the script, but pretty much we are going to create this whole release in GitLab, and this is a GitLab feature pretty much. Now, once we have this release, we are going to move on to deploy this release to frontend A. And what this does, this extends the deploy frontends template, but also it triggers a deployment type job in my group A frontend A project. Now, I know this can be a bit hard to follow along as we have multiple references, but let's go to the project. Let's create a new tag and see what happens. So we are going to create tag 3.6.1. We're going to click on create. We see the tag right here, even though the latest update was performed a while back. But if we go to the pipelines, we can see how the pipeline looks like. We are going to start to build the application, and you can go into the terminal output and you can see how that looks like as things are unraveling. And this is a pretty basic pipeline, just 2 stages, 3 jobs. Let me go back to my older pipelines and let's look at a pipeline that doesn't have a tag attached to it. So we do have a commit on the master branch that I performed a while back. And as you can see right here, this looks different. Pretty much we are building the app again, but we are just running tests against it. We don't want to do anything else. That's the logic behind it at this point. We've done the deployments, we've done commits, we've done developments, we've done commits. We validate them, and at one point when we are ready to release, we create the tag, and the other pipeline will get executed. Now, as you can see, this pipeline is blocked. So what happened is that we built the container, we used the release job to create a release for it. Now, if we go into the container registry, we can see our image right here. Here it is, 3.6.1. Even though it was published 2 hours ago, I don't know why that happens. And now we have the option to do a manual deployment. In the current setup, triggering a deployment will trigger a downstream pipeline, multi-project pipeline in my front-end project A. And now we're starting to deploy on production. And the same happens for the backend as well. And I want to show you another thing. So in this CI YAML file, we've seen where we are including the files, the templates. Now let's look at the template files itself and see how that looks like. Here I have a project and I tried to replicate that centralized pipeline template repository structure. I have a file for each template and I know what it means based on the name. So I can at any given point in time in any of my projects, I know that in my front-end project, I want to deploy front-ends. Currently I'm deploying one, but if I wanted to add another one for deployment, it's just a matter of copy pasting this, referencing to front-end B, for example, creating a different project for it, and that's it. So this is way more scalable. Also going back to group A and the project itself to show you what happens is here I have another pipeline that you saw me triggering. The content of the pipeline is pretty simple. As you can see, I'm using some variables to configure the front-end app at runtime. And then I'm using the deploy instance template to do the deployment. And if I want to see what's that about, I can go into my CI templates project. I do have the deploy instance over here, and I can go in and I can look at it. It's pretty much the deployment part of the auto DevOps pipeline that we do provide. I hope this makes sense. It's a way of showing you how everything ties together and how these can be used to achieve release management with GitLab. Are there any questions? Was this useful? Yeah, thanks for that feedback, Mitchell. That was the purpose of the session. There's a lot of content out there. There are lots of options that you can have with GitLab. The idea is, even though it was advanced, it was getting you started with the advanced stuff and not jumping in the deep end with the advanced configurations of the advanced stuff. Any questions that... is there a way to provide parameters to templates instead of variables? You might use the same variable name in a previous job task, but you might want to pass a different value to a template. Parameters to templates. So if you... I'm not sure I understand the question exactly. But if... And yeah, Cristian Popescu, if you want to elaborate on that, you can unmute yourself. You can, with templates, you can customize them for the extents within the project that you use them. And I think this is important to take into account, that you do have control at the project level. You don't want the same variable names necessarily, but what happens is that project takes precedence depending on how you configure it over the template. I'm not sure I was clear. That's a clear answer.
Hello, Vlad. Hello, everybody. I don't know if you can hear me.
Yeah.
So,
Hey, Christian.
My question is like the way I'm treating templates in different project is like a function. So function gets as an input parameters, so you can pass absolutely any value to a template. It doesn't depend. It's not really dependent on a variable name or something like that. So this is what I wanted to know, if that's possible within GitLab.
So templates aren't necessarily as functions, and I don't think you can use them as such. But if you want to send parameters to templates, you can definitely do that. So for example, let's go back to my deployment. sorry for that, to the front-end A application. So we do have the front-end pipeline, which builds and releases and can trigger deployments of this. And let's say you want to decide if I'm going to do a deployment for front-end A, or do I want to deploy for some of the others, and decide that on the fly. You can do that through variables, and you can have rules over here and rules in the template itself. And I can send variables from this section right here into the pipeline that I'm triggering. And that's a way of parameterizing, in a way, what happens in the downstream pipeline, if that makes sense.
Yes, it does. My point was, if the variables names were really dependent on what values you pass, because all I wanted to know is if the variable name is really mandatory in that situation, or a template could get any variable, but as a parameter, you know. That's
you need to use variable names. You need to use variable names, any variable name, it doesn't really matter, but you need to have it as a variable, pretty much.
All right. I understood now. Thank you.
You're welcome. Thank you for your question. So we do have another question from Andrei. Can a custom variable be used in rules be changed in previous stage to skip a job in the next stage? I think you can overwrite variables, but you need to be careful how you're going to structure your pipeline, because, and that's possible, it's an even more advanced use case. As I mentioned at one point, pipelines are decided, if you will, on the trigger. So I'm doing a commit, GitLab will take that source code, will take my YAML file, and it will decide, hey, all this set of jobs need to run. Now, if that decision is already made and you want to skip a job, you would need a special mechanism. But I think that's achievable. Christoph, do you have any ideas about this?
As usual, there might be multiple solutions, but I think that might be a good use case for dynamic pipelines, which is essentially going to evaluate a couple of things and allow you to generate the rest of your pipeline there as well. That might be a way to do it. On topic of variables, and that goes for Christian's question as well, potentially, we just released a new feature which allows you to set your variables based on the rules as well. So if during the rules you select, for instance, that the branch name contains production, or the environment is something, or whatever the rule it is, can override that variable's value as well, which might be used in both cases potentially.
Yeah, thanks for that.
You're welcome.
Any other questions or feedback or?
If your question is too long to type, just ping us in the chat and we'll allow you to talk, just like we did with Christian.
If we don't have any other questions, thank you for your time today. I do hope this was a useful session and gave you some insights around what's possible with GitLab CI in the more advanced use cases. And if you like the format, if you like the content, we are going to have other sessions in this whole demo series, as I think you already saw on the webpage. So hope to see you in the next one. Thanks everyone. Take care. Bye.